Hello everyone, welcome back for another video. Today's lesson will be on factorization involving cubics and common brackets. So let's have a look first at the cubic factorization formulas. There are two formulas that involve cubic factorization, one being x cubed minus y cubed and the other one being x cubed plus y cubed. And x cubed minus y cubed factorized into x minus y times x squared plus xy plus y squared, and the x cubed plus y cubed factorizes into x plus y, x squared minus xy plus y squared. Now these two formulas have a lot in common, but then there are distinct differences as well, essentially in the signs. So what we notice, and one little trick that I use to help me remember these formulas, and some of the students may find this useful, is that the first bracket always matches the sign of the cubic factorization. So if you've got a minus x cubed minus y cubed here, the first bracket will be x minus y. And if it's x cubed plus y cubed is a factorization, the first bracket is x plus y. Now the sign of the next sign in the next bracket will always be the reverse. So if it's minus here, it will be plus there. And if it's plus here, it will be minus there. And the last term always being positive, y squared. Now let's have a look at an example. 3y cubed minus 81. Now clearly that can't be factorized directly into a cubic factorization because it's not in that format yet. So let's have a look at how we do that. The first thing we need to do is factorize the 3 outside, leaving us y cubed minus 27. And now we can see that the y cubed minus 27 is a cubic factorization, and it is of the first formula format. So what we need to do there is simply substitute those values into the formula, and we can see very clearly that in our particular case the x is actually y, and y cubed being 27, making y the value of 3. So we simply substitute those values into the formula. So x being y, so that's y, and y being 3, so that's y minus 3. Obviously the 3 just carries forward from before, so 3 outside of y minus 3. The x squared becomes y squared, and then x being 3, x being y and y being 3 gives us 3y, and then 3 squared giving us the 9. Next is the factorization involving common brackets. So let's have a look at an example for a plus a squared plus 4b minus b squared. So let's have a look and see how we do that one. What we need to do first is to group these terms together, the second and the fourth, and the first and the third. These ones being a quadratic factorization, a squared minus b squared becomes a perfect square, a minus b outside of a plus b. And then factorizing the first and third term, the common factor is 4, leaving us a plus b. Now we notice that the a plus b here and the a plus b there are in common. So we factorize the common brackets, a plus b and a plus b, and the front terms can then join together to form their own bracket. So the a minus b, the front term here, and the 4 can then join together to form their own bracket, giving us the final solution of a plus b, the common bracket, and the remaining terms forming their own bracket, a minus b plus 4.